Question number 24, page 245, says that our bakery is selling bagels. It sells more when the price goes down, but then its profit changes. This is an equation for the bakery's profit. X is the price of bagels. Very similar to question number 23. Now it wants to know what the highest price that the bakery can charge to make a profit of at least $200. So let's make profit 200 by plugging 200 in for Y. And that should give us the price, or prices, that would give you a profit of exactly $200. Getting our equation equal to 0. Let's move everything over to the left side. Generally, it's easier to work with a positive leading coefficient. So adding 1000x squared to both sides, subtracting 1100x, and adding 2.5. Let's solve by using the quadratic formula. You could also solve it by graphing, especially if it's a calculator problem, which I would assume this would be. Solving by graphing is probably going to be the fastest way, but it is in the quadratic formula section, so let's use that. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Simplifying the discriminant, the stuff under the square root there, I've got 1100 squared minus 4 times 1100 times 202.5. So 1100 plus or minus the square root of 319,000 all over 2,000. So I have 1100 plus the square root of that divided by 2,000. So 83.2 cents. Let's round to the nearest cent. $1,100 minus square root of 319,000 divided by 2,000. 27 cents. This parabola opens down. So there's 27 cents. There's 83 cents. As I plugged in 200, got my equation equal to 0. Notice everything in between those two, our profit is more than what we're looking for, so more than 200. It wants the highest price we can charge to still make a profit of 200. So that should be at this point here, which is the bigger of the two, which is the 83 cents. Technically, it's 83.2 cents, so 84 would be too much. So yeah, 83 cents.